Hello student, good morning. I am Dr.A.J. Kumar Sinha, Professor of Chemistry. Today I am going to discuss reaction of phenols. Last class I have discussed electrophilic aromatic substitution. Under that I have discussed nitration and also I have discussed halogenation. Now I am going to discuss Kolbe reaction. What is actually Kolbe reaction? That I am going to discuss now. I am continuing from the last class. That is a reaction of phenols. Under that I am going to discuss Kolbe reaction. Phenoxide ion generated by treating phenol with sodium hydroxide is even more reactive than phenol towards electrophilic aromatic substitution. Hence, it undergoes electrophilic substitution with carbon dioxide, a weak electrophile. Orthohydroxybenzoic acid is formed as the main reaction product. Its reaction is very simple. Phenol in presence of sodium hydroxide, it gives sodium phenoxide. Phenol in benzene OH is there. OH group is attached. In that H is replaced by sodium. It is called sodium phenoxide. Now this reacts with carbon dioxide. Acidic medium, and after the reaction it will give salicylic acid, means carboxylic acid is introduced. Sodium phenoxide, when it reacts with CO2, carbon dioxide gas, in presence of acid, means acidic medium, then it gives salicylic acid, means 2-hydroxybenzoic acid. Carboxylic group is introduced. Okay. Then in Kolbe reaction, what happens? That phenol is converted to salicylic acid, means 2-hydroxybenzoic acid. Now next reaction I am telling you. Reimer-Tiemann reaction. Reimer-Tiemann reaction. On treating phenol with chloroform in the presence of sodium hydroxide, a CHO group is introduced at ortho position of benzene ring. This reaction is known as Reimer-Tiemann reaction. REIMER, Reimer-Tiemann, TIEMANN, Reimer-Tiemann reaction. The intermediate substituted benzyl chloride is hydrolyzed in the presence of alkali to produce salicylaldehyde. In this reaction also salicylaldehyde is produced. Then here again I am telling you a stepwise reaction. Phenol reacts with chloroform and aqueous NOH, and it will give intermediate product. What will happen here? That first H of phenol is replaced by sodium first, and after that at carbon number 2 CHCl2 is produced is attached. Because chloroform we have used, then in carbon number 2, that one hydrogen and chloroform, one chlorine, it makes HCl, and remaining CHCl2, it attaches to carbon number 2. Correct? Because from this carbon, hydrogen is going as a H plus, hence carbon becomes negative. Carbon becomes negative. And from CHCl3 means chloroform, Cl went as a, by taking its negative charge. Then remaining will become CHCl2, that will be positive charge. Means carbon will become positive charge. That carbon of chloroform, now after leaving the Cl, what is remaining, that carbon is, or carbocation you can tell, is positive. That reacts with negative carbon of phenyl, or this carbon number 2 in benzene ring. After leaving the hydrogen, carbon became negative. There this CHCl2 will join. Okay, then now it forms a intermediate, means with benzene ring ON is attached, and second CHCl2 attached. This is the intermediate product. It is unstable, and on further with reaction with NOH, that CHCl2 converts to CHO, means aldehyde group is attached. Okay, then now here you can say this happened with reaction with NOH. Okay, then here CHCl2 actually reacted with NOH, and this Cl2 of CHCl2, that reacted with Na of NOH. Then now in this way oxygen is introduced there with intermediate, and it formed CHO. Correct? Then now we got from phenol, we got that is now in this ring aldehyde is introduced. CHCl2 in presence of NOH converted to CHO. And now after the acid hydrolysis, CHO converts to salicylaldehyde. In the Colway reaction, we got salicylic acid, COOH was introduced. Now CHO is introduced. Correct? And after the acid hydrolysis, that Na, what was ONA, phenoxide, that Na now replaced with hydrogen. Now we got salicylaldehyde, means in benzene ring one OH group is there and one CHO group is there. Then this is called salicylaldehyde. Then now from phenol we got salicylaldehyde. This is actually called Reimer-Tiemann reaction. Reactions involved in conversion of phenol to salicylaldehyde is called Reimer-Tiemann reaction. This is very, very important reaction. Question is asked in almost all exam. Now next chemical reaction I am telling you, reaction of phenol with zinc dust, Zn powder. Reaction of phenols with zinc dust. Here phenol will be converted directly to zinc. from phenol you will get Zn, and you will get benzene. In presence of Zn, phenol will be converted to benzene. Okay, OH of the phenol is removed. Okay, and it converts to benzene. Means phenol plus Zn. Phenol plus Zn, it gives benzene plus ZnO. Here O reacts with Zn and it forms ZnO, and H is now it is attached to benzene ring. After leaving the oxygen from OH, H will make a bond with carbon, and now it will convert it to benzene. Next reaction I am telling you, oxidation reaction. Oxidation of phenol. This is again very important reaction. Oxidation of phenol. Oxidation of phenol with chromic acid produces a conjugated diketone known as benzoquinone. Again, I am telling you, oxidation of phenol with chromic acid produces a conjugated diketone known as benzoquinone. In the presence of air, phenols are slowly oxidized to dark colored mixture containing quinones. Means reaction is very simple, that phenol plus Na2Cr2O7 in presence of H2SO4. Now 2 oxygen is introduced in the benzene ring. Correct? At the ortho position, this one is 1,4, you can tell. 1,4. Correct? Oxygen is attached with carbon 1 and carbon 4. Okay. 2 oxygen is introduced, means carbon and oxygen double bond at carbon number 1 and carbon number 4. This is called benzoquinone. Okay. This I have told about the oxidation. Now I am going to tell these things. Some commercially important alcohols. I want to tell that about the important products, important alcohol. You can tell. I want to tell you about the important alcohols. Methanol and ethanol are among the 2 commercially important alcohol. Correct? These 2 are very important. Then first I want to tell about the methanol. CH3OH. CH3OH, also known as wood spirit. Methanol CH3OH is also known as wood spirit. Question is asked. It was produced by destructive distillation of wood. This methanol, which is called wood spirit, was produced by destructive distillation of wood. Today, most of the methanol is produced by catalytic hydrogenation of carbon monoxide at high pressure and temperature at high temperature and pressure in the presence of ZnO, means zinc oxide, and chromium oxide, Cr2O3. Then here CO plus methanol, how it is produced, I am telling you reaction CO plus 2H2. Then here obviously 1O is there, CO, carbon monoxide, plus 2H2 means 4 hydrogen. Then just these 4 hydrogen will join with carbon, 3 with carbon, 1 with oxygen, and it will form CH3OH. Here oxygen double bond CO, in CO oxygen is carbon oxygen is double bond, that will break. That double bond will become single bond, means pi bond will break. Then obviously one oxygen will be negative and carbon will be positive. Then here methyl, this 2H2 means hydrogen gas is there. Then when H2 will break, it will form H plus and H minus. H plus and H minus. Then now one H plus will go to the O and it will form OH. And now with plus carbon CO, that carbon is a plus. Now there one minus will go. Hydrogen will go there. Then now here you can say 2 hydrogen is introduced. 2 hydrogen is introduced. Now to introduce two more hydrogen, this condition ZNO and chromium oxide Cr2O3 in presence of 200, you can say 200 to 300 atmospheric pressure, very high atmospheric pressure, and temperature is also high, 573 to 673 Kelvin. That is applied. Then now again further two hydrogen just attached to the carbon. Then here by this reaction you will get CH3OH, methyl alcohol, means CO plus 2H2, very simple reaction, CH3OH. Methanol is a colorless liquid and boils at 337 Kelvin, means roughly not exactly 100 degrees centigrade. It boils at 100 degree centigrade. 300, this is 337 Kelvin, not 73, 337 Kelvin. Then 337 Kelvin you can convert in degree centigrade. 337 minus 273. Then you will get in degree Celsius. Then 273 means 27 degree and plus 37. That is it. In degree it will become 37 plus 273 means 27 degree and 37 degree. Just to add it 37 plus 27. Then you will get how much? 30 plus 20, 50 plus 14, 64. Means methanol boils at 64 degree Celsius, or you can tell 337 Kelvin. It is highly poisonous in nature. You always remember, many people in the name of alcohol, they will drink it. But as a chemistry student, you must know it is a deadly poisonous. Methanol is deadly poisonous. Okay, you must know about this. Many people, just alcohol is there, they will drink and they are dying. It is a deadly poisonous. You tell your friends also, those who are not knowing the chemistry, they should not drink methanol. Then methanol is a deadly poisonous, or you can say poisonous in nature. Ingestion of even a small quantities of methanol can cause blindness, and large quantities causes even death. Even a small quantity of methanol can cause blindness, means person will become blind. It affects the eye, and large quantities causes even death. Methanol is used as a solvent in paints. Now this is important use. Methanol is used as a solvent in paints, varnishes and chiefly for making formaldehyde. It is also used for formation of formaldehyde, means HCHO. Now just come for the ethanol. Ethanol, very important alcohol. Generally, alcohol means people will understand ethanol. Okay, ethyl alcohol. Generally, people will understand ethanol, but in chemistry, many alcohols are there. Methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol, ethyl methyl alcohol. Many are there. But in general way, alcohol means people will understand ethanol. Okay, ethyl alcohol is known as ethanol. Ethanol, that is the C2H5OH. How it is prepared, I am telling you. Ethanol is obtained commercially by fermentation. Question is asked. Okay, this is actually oldest method. Fermentation is the oldest method to form. It is actually fermentation is the oldest method, and it is prepared from sugars. Fermentation means formation of ethanol or ethyl alcohol from sugars. It is the oldest method. The sugar in molasses, sugar cane or fruits such as grapes is converted to glucose and fructose, both of which have the same formula C6H12O6. Glucose and fructose both are isomer, both have same formula C6H12O6. Then here what happens actually, that after crystallization of sugar, some liquids are remaining. Some liquids will be remaining. That liquids are called actually molasses. The sugar in molasses, actually in that liquid, some sugar will be present. After the crystallization, some liquid will get. In that liquid also, sugar may be present. That is called molasses. The sugar in molasses, sugar cane or fruits such as grapes is converted to glucose and fructose in the presence of an enzyme. What is the name of enzyme? Invertase. 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 Generally in enzyme, last three letter will be ASE. Age. Here name is invertase. Then how we will convert, you can say, sugar into alcohol? Then here one enzyme is required. That is called invertase. Actually it is a two-step. First you will convert to glucose and fructose. That is done in the presence of invertase. Actually glucose and fructose first from the molasses. Molasses means here sugar. Sucrose C12H22O11, ordinary sugar. That is also found in these things, grapes. Then from that sugar, first this sugar that is converted to glucose or fructose in the presence of enzyme called invertase. Okay, one step is over. You got glucose and fructose. Both have same chemical formula. Both are isomer. But glucose has aldehyde group and fructose have ketonic group. That is the difference between fructose and glucose. Glucose is aldehyde group. Glucose has aldehyde group and fructose has ketonic group. This is the difference. But molecular formula is same. IIT Advanced, this type of question has been asked many times. Okay, in other examination also. Difference between glucose and fructose. Correct? Then now this is the first step, that from the sugar means sucrose C12H22O11 plus H2O. Actually it is hydrolysis. Then C12H22O11 plus H2O. In presence of invertage, you will get glucose, 1 mole of glucose, 1 mole of fructose. And after that, this glucose or fructose, in presence of another enzyme, that is called zymase, ZYMASE. Here also in the last ASE is there. Okay, zymase, remember zymase. Then in the presence of zymase, that glucose or fructose, any one or both, that will convert to two products. First main product will be alcohol, 2 molecules of alcohol, C2H5OH, 2 molecules, 2 C2H5OH, C2H5 2 molecule, plus carbon dioxide, 2 moles of carbon dioxide, 2 moles of ethyl alcohol you will get. Correct? Generally in our body, after we are eating food, after we eat food, then when this food will react in the body, then this reaction also takes place, because our food has carbohydrate, maybe sucrose, maybe glucose, maybe fructose. Then also you can tell these things, bigger unit of sugar, okay, that whatever bigger unit, a starch, what you are telling, a starch, then a starch is a bigger unit of sugar, you can tell. Then a starch converts, first a starch will convert to this sucrose, means C12H22O11, and this sucrose converts to glucose and fructose, a smaller unit, a smallest unit of sugar, you can tell, a smallest unit of sugar. And this you can say glucose and fructose, in the presence of zymase, it converts to ethyl alcohol and carbon dioxide. And due to this formation of ethyl alcohol and carbon dioxide we releases, and we feel sleepy after taking food, particularly rice. In that it actually gives more alcohol. Due to the formation of alcohol in the body, we feel sleepy, and other product is carbon dioxide that we release from our nose. Then this process 24 hours continues. We can't live without food. If we will not eat any food, then this process will stop. Actually, in presence of oxygen also this reaction takes place. Then that time it will form more carbon dioxide. Actually, that what we eat, that burns in our body, churning, you can tell. It burns in a combustion, you can tell, combustion. Then for that oxygen is required. Then it will burn just like any other burning. Oxygen is required. Inside the body also oxygen is required. That's why we are taking oxygen from the air every time, every minute, you can tell, we are taking oxygen. For what purpose? Only to main purpose. Many purposes are there, but one major purpose is to burn this, you can say, food what we have eaten, for combustion purpose, for churning purpose. We are this oxygen this oxygen is used multi-purpose, but here main purpose is just for combustion of carbohydrates. Whatever we eat food, it will burn. That time for the burning purpose oxygen is required, and it gives main two product. That time it will give when it will burn in presence of oxygen. That time in presence of oxygen, it will give more carbon dioxide, CO2, and water vapor, H2O. That's why with carbon dioxide, if you see, then water vapor will also come. Water vapor also comes with CO2, carbon dioxide, when we are releasing. And third product, important product, that is the heat. Okay, after burning, it produces more heat energy. That's why whenever carbon dioxide comes from our nose, it will have carbon dioxide plus water vapor plus heat. It will be born. You check it either from the mouth or from the nose. This carbon dioxide may come. Generally, it will come from the this nose only, but sometimes it will come from mouth also. Then water vapor, whatever is coming from the mouth, that is also warm, and then from the nose, whatever carbon dioxide is coming, that is also warm. This is due to this reaction only, combustion reaction. Then this reaction is called aerobic in presence of oxygen, but sometimes in absence of oxygen also carbon dioxide is produced. That is called anaerobic. AN you can add in aerobic, anaerobic. Then I told you that this from the sucrose, first you will get glucose and fructose in the presence of invertage, but here hydrolysis will take place, means C12H22O11 plus H2O that is required essentially. Only then you will get glucose and fructose. Then any one or both in presence of Zyme, it will convert to alcohol plus CO2. Now you can know little more and interesting things. In wine, you might have 100% people might be knowing wine. In wine making, grapes are the source of sugars. Wine is made from the sugar. This wine is made from the sugars. But what is the main things? Source of sugar. The source of sugar is grape. Okay. In wine making, grapes are the source of sugars, and yeast. YEAST. Yeast is enzyme. Then you require grapes and yeast. Okay. Then in wine making, grapes are the source of sugars and yeast. As grapes ripen, the quantity of sugar increases and yeast grows on the outer skin. Again, you remember, only in grapes, when that it will ripen. As grapes ripen, the quantity of sugar increases and yeast grows on the outer skin of grape. Yeast you have to, actually it is available in the market also, but now automatically on the skin of grape, yeast will deposit. Okay, when grapes ripen, that time, when grape ripens, the quantity of sugar increases and yeast grows on outer skin. When grapes are crushed, sugar and the enzymes come in contact. Means enzyme which was on the skin of grape. When you will crush the grapes, then sugar will come out from the grape, and when it will come in contact with the enzyme which was on the skin, then what will happen? Now reaction I told you. When grapes are crushed, sugars and the enzymes come in contact and fermentation starts. Fermentation takes place in anaerobic condition, means in absence of oxygen. In absence of oxygen, that is called anaerobic condition. That is in the absence of air, this reaction takes place. Carbon dioxide is released during fermentation. Very, very important things I told you. Now, actually, I want just to tell more about the ethyl alcohol. Ingestion of ethanol, actually, you can say excess of everything is bad. You always remember, anything in excess is not good. Here also you should know. Ingestion of ethanol acts on the central nervous system. Just to listen carefully. Ingestion means if you will drink the alcohol, then what will happen? That I am telling you. Ingestion of ethanols acts on the central nervous system. In moderate amounts, it affects judgment and lowers inhibition, you can tell. If it is taken in moderate amounts, it affects judgment and lowers inhibition. You can't make any judgment. And higher concentration, if you drink more, then what will happen? Higher concentrations causes nausea and loss of consciousness, means you will become senseless. Higher concentration cause nausea, 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 you know, and loss of consciousness. You will become just like a senseless, no sense, consciousness. Even at higher concentration. This I told you, higher concentration. Even at higher concentrations, it interferes with spontaneous respiration. If it is taken in a higher concentration, then other effect I am telling you, it interferes with spontaneous respiration and can be fatal. Person can be in big trouble, can die also. Okay. Then this creates big problem, fatal, you can tell, fatal. Now come to the properties of this ethyl alcohol. The action of, little more about the gymase, I am telling you. The action of gymase is inhibited once the percentage of alcohol formed exceeds 14%. This from glucose or fructose. In presence of gymase, alcohol is formed, alcohol plus carbon dioxide. But now we will just listen that the action of gymase means enzyme, enzyme or yeast, what you can tell. The action of gymase is inhibited once the percentage of alcohol formed exceeds 14%, 1/4. If air gets into fermentation mixture, the oxygen of air oxidizes ethanol to ethanoic acid. You know that alcohol can be converted to acid. Then if air gets into fermentation mixture, the oxygen of air oxidizes ethanol to ethanoic acid, which in turn destroys the taste of alcoholic drink. Okay, now I am telling you properties. Ethanol is a colorless liquid, no color, with boiling point 351 Kelvin. It is used as a solvent in plant industry. Its main use is in plant industry as a solvent and in the preparation of number of carbon compounds. The commercial alcohol is made unfit for drinking. Knowingly, it is made unfit for drinking by mixing it some copper sulfate. You remember here, knowingly that to make it unfit for drinking, what is added? It is mixed with some copper sulfate to give it a color. It is a colorless, but if it is a colorful, one should not drink, because that color means copper sulfate. Little amount of copper sulfate is mixed, then it produces color. Okay, copper sulfate is blue, you know, color is blue. Then here some this I told you that some copper sulfate is mixed. Okay, so that people should not drink. And also what is mixed? Then pyridine is also mixed. Two things are mixed to stop drinking. First, in the ethyl alcohol, two things are mixed to make it unfit for drinking. Then first is copper sulfate and second is pyridine. It will give a foul smelling liquid. Foul, F-O-U-L. You can't drink, very bad smell. Very bad smell, foul smelling. And this alcohol is known as denatured alcohol, and process is known as denaturation of alcohol. Question is asked, what is the denatured alcohol? What is the denaturation? Then remember, when a little quantity of copper sulfate and pyridine is mixed in the alcohol to make it unfit for drinking, that process is known as denaturation, and this alcohol is called denatured alcohol. Okay. Nowadays, large quantities of ethanol are obtained by hydration of ethene, double bond ethene. From the ethene, nowadays alcohol is made in large quantities. Okay. Now I want to tell you that preparation of ethers. Okay, today I will discuss only next class properties, and properties of ether I will discuss in the next class. Now I want to discuss these things, preparation of ethers. First preparation I am telling you, by dehydration of alcohol. Then here dehydration, you know, meaning of dehydration, removal of water. By dehydration of alcohol, first method now I am telling you, alcohols undergo dehydration in the presence of protic acid. Example of protic acid means H2SO4, H3PO4, sulfuric acid, phosphoric acid. Why? Because it produces H+. That's why it is called protic acid. Then alcohol undergoes dehydration in the presence of protic acids. The formation of the reaction product alkene or alkene or ether depends on the reaction condition. Means it will form alkene or ether. That depends on the reaction condition. For example, ethanol is dehydrated to ethene in the presence of sulfuric acid at 443 Kelvin. At 443 Kelvin. Okay. At 443 Kelvin, and at 413 Kelvin, 413. That is the ethoxy ethane is the main product. Question is asked. Actually, due to the temperature difference, you will get different product. This is the important. You remember, when temperature is high, 443, then you will get ethene. But in presence of H2SO4, both reaction you will get both product from the ethanol only. From the ethanol, you will get two product only by differing the temperature. At 443 Kelvin, you will get alkene, double bond, CH2, and at 413, you will get ether, diethyl ether, means C2H5O, again C2H5, diethyl ether. Okay, then here temperature is important. The formation means reaction is very simple. CH3CH2OH, this is ethyl alcohol. Then ethyl alcohol in presence of H2SO4 at 443 K, it will give CH2, means alkene, ethylene. And at 413, less temperature, little less, in presence of H2SO4, it will give ether, C2H5O, C2H5. This is the very, very important reaction. How will you get ether? I have told you. On the formation of this thing, again important point I am telling you, diethyl ether has been used widely as an inhalation anesthetic. Anesthesia. Just in hospital they will use as anesthesia. Inhalation is used as on this diethyl ether has been used widely as an inhalation anesthetic, but due to its slow effect and on unpleasant recovery period, it has been replaced as an anesthetic by other compounds. That sometimes patient takes more time to get conscious. Okay, that's why now this is not used. Now it is replaced as an anesthetic by other compounds. Okay, because this is due to the slow effect and an unpleasant recovery period. Now again I am telling you further preparation. Acidic dehydration of alcohols to give an alkene is also associated with substitution reaction to give an ether. From ether you can also get this thing. To get ether from alkene also it is possible. That is the acidic dehydration is required. Acidic means alcohol. From the alcohol you will get alkene. From alkene you can get ether also. Okay. Acidic dehydration of alcohol to give an alkene is also associated with substitution reaction to give an ether. The method is suitable for the preparation of ethers having primary alkyl group only. The alkyl group should be unhindered and the temperature be kept low. Otherwise, the reaction favors the formation of alkene. The reaction follows SN1 pathway. This reaction follows SN1 pathway because it is the nucleophilic substitution reaction. The reaction follows SN1 pathways when the alcohol is. First you understand that this reaction follows the SN1 pathways. Condition I am telling you, the reaction follows SN1 pathways when the alcohol is secondary or tertiary. The reaction follows SN1 pathways when the alcohol is secondary or tertiary. Okay. And this question is also asked which reaction follows SN1 or SN2. Then this is the SN1. First order reaction in 2 steps, you remember. Now further I am telling you that this dehydration of secondary and tertiary alcohols to give corresponding ethers is unsuccessful. As why it is unsuccessful? As elimination competes over substitution, and as consequence alkenes are easily formed. Because in this reaction ether is forming, but possibilities for formation of alkene also. Okay. The dehydration of secondary and tertiary alcohol. Primary alcohol is no problem, but secondary and tertiary I am talking about. The dehydration of secondary and tertiary alcohols to give corresponding ether is unsuccessful, as elimination competes over substitution, and as a consequence alkenes are easily formed. Okay, this I have told you one preparation. Now next preparation I am telling you Williamson synthesis. Williamson, name of scientist is Williamson synthesis. What is this synthesis? Williamson synthesis. It is an important laboratory method for the preparation of symmetrical and unsymmetrical ethers. In this method, an alkyl halide is allowed to react with sodium alkoxide. Okay. Here is a lab method. It is an important laboratory method for the preparation of symmetrical and unsymmetrical ethers. In this method, an alkyl halide is allowed to react with sodium alkoxide, means Rx plus, here Rx means halide, alkyl halide, plus what is required? Then in this method an alkyl halide is allowed to react with sodium alkoxide, means RONA. Na is positive charge, oxygen is RO is negative, ROO is negative, Na is positive. This is called sodium alkoxide. Then how you can understand? Reaction is very easy to understand. Rx is there plus RONA. Then Na will go to X and it will form NaX. And because Na will go, then obviously RO is negative, then it will come to R. Rx was there, X gone as X minus. Then R will be positive. R will be positive. From that RO, O will join with R. O will join with the R of Rx. R of Rx means RO R dash. Suppose R dash is sodium methoxide or alkoxide, then alkoxide, that suppose that was the R dash. RO was R dash. Then it will form RO R dash. This is the ether. And other product is NaX, sodium halide. Sodium halide. Then now ethers containing substituted alkyl group. Ethers containing substituted alkyl groups may be secondary or tertiary, may also be prepared by this method. The reaction involves SN2 attack of an alkoxide on the primary halide. Remember, now here SN2 reaction will take place, second order reaction in one step. Okay, then here in this the reaction involves SN2 attack of an alkoxide on primary halide. Okay, this reaction is also very important, and question is asked. Now reaction you can understand again easily. Okay, suppose tertiary alcohol you are talking about, then carbon will attach with 3 alkyl group. Then here you can take, that is alkyl, sodium alkoxide is there, ONA. Now this ONA is attached with the carbon, and that carbon is attached with 3 alkyl group, correct? Then now you understand, when this alkoxide reacts with you can say CH3Br, methyl bromide. Alkyl halide means here you are taking example methyl bromide. Then what will happen? Then here again already told you, sodium will come to bromine atom and it will go as a NaBr, and because from the methyl group bromine has gone with electron, hence methyl carbon will have positive charge, and there O will join, because Na gone from the alkoxide, Na as a Na plus, the O is negative, then negative O will join with carbon, which is positively. Then now you will get CH3O, and again this one methyl group attached with the oxygen. Very simple way. Carbon was having 3 alkyl group, correct? And that ONA was there, Na gone, O is negative. Then from this negative part will join with positive of methyl group. Methyl group means halide. Sodium halide was there, that methyl group I am talking about here. Then now we will get ether plus other product sodium bromide. Okay. Better results are obtained if the alkyl halide is primary. In case of secondary and tertiary alkyl halide, elimination competes over substitution. If a tertiary alkyl halide is used and alkene is the only reaction, only the reaction product, only one product you will get, alkene, and no ether is formed, no ether, only alkene you will get if we are using these things secondary and tertiary. Generally possibility is there, it's ether can form, but there will be competition. Better results are obtained if the alkyl halide is primary. That time good, you will get ether. In case of a secondary and tertiary alkyl halide I am talking about, where bromide was attached, I am talking about that. Then if you can say, in case of a secondary and tertiary alkyl halide, elimination competes over substitution. If a tertiary alkyl halide is used and alkene is the only reaction product and no ether is formed, Here I am not talking about the alkoxide, sodium alkoxide. I am talking about this halide. Alkyl halide should not be secondary or tertiary. Primary is okay. In secondary or tertiary case, it will not give ether. Okay, no ether is formed. For example, the reaction of alkoxide like the CH3ONA plus tertiary halide means that halide had that carbon from which bromine is attached with 3 alkyl group. If both will react, sodium methoxide and tertiary halide, then what will happen? That what we were thinking, NaBr will go outside. No, this time it will not form NaBr. It will form NaBr, but one more product it will form. Not only sodium bromide, one more product will form. That is the ethyl alcohol. Because now you can see this tertiary bromide has 3 methyl group. Then one methyl group and one hydrogen from the second methyl group. There are 3, then one methyl group and one hydrogen from the other methyl group. That will come out. Then what will happen? Because one H gone, then it will go, when it will go as a H plus, then that carbon will be negative charge. H is going as H plus, and that carbon will be a negative charge. And here this methyl will go as a negative charge. Methyl group will go as negative charge. Then carbon will have positive. Okay. Then it will make double bond. Then you will get CH3, CH3, C double bond CH2. Okay, plus NaBr plus methyl alcohol. Means it is called 2-methyl propene. 2-methyl propene you will get. Correct? Then here you can see what happened here. This thing CH3, 3CH3 was there. Then here what will happen? That one CH3 will form a CH3OH methyl group. This methyl alcohol, CH3 and OH, because one H went from the other methyl group. Then only the 2H2 is remaining, and carbon became negative. And one methyl went. When one methyl went out, that time carbon became positive. Then positive and negative, they made double bond. And then now it formed propene. Propene CH3C double bond CH2. Correct? CH3, 2 methyl group was remaining. Correct? And now with central carbon, that formed double bond. Now it became CH3, C again CH3 and other CH2, that is the double bond, C and CH2. Okay. Then now how you got this 2-methyl propene, I have told you. Okay. And 3 product means one is the 2-methyl propene and one sodium bromide, one methyl alcohol. Here one point I want to tell you, point out that NaOCH3 is there. NaOCH3 alkyl is there. Actually, what will happen here? NaOCH is there. Then, like other reaction, it will go as a NaBr. Then NaBr. Na plus Br will go. Other means I am telling you possibilities that if methyl group is not going, then what will happen? That because for the double bond, one negative and one positive carbon is required. Then when one hydrogen gone as a H plus, then that carbon got negative. And if bromine has to go, then bromine it will go as a Br minus, then that carbon will have positive. Then this negative and positive will make bond, double bond. Then in that situation, all three CH3 will remain. In that situation, all CH3 which was attached to the carbon will remain. And carbon number, central carbon and any other carbon out of 3, that will make double bond, because hydrogen can go from any methyl group. Then it will form 2-methyl propene. 2-methyl propene, total 4 carbons. Okay, 3-methyl, and this 3-methyl groups attached with the carbon, total 4. Then from the central carbon, bromine gone, then that carbon got you can say positive charge, and from the methyl group, hydrogen gone as H plus, that carbon became negative, and positive negative will make double bond. One bond already was there, other bond also formed. Then now we will get CH3 and C and CH2 double bond. Other two product will be NaBr and ethyl alcohol. It is because alkoxides are not only nucleophile, but here you can see that you are not getting ether, you are getting alkene. Ether you are not getting. Why you are not getting ether here? It is because alkoxides are not only nucleophiles. Alkoxides are not only nucleophiles, but strong bases as well. They react with alkyl halide, leading to elimination reaction. Means here elimination reaction is what? Elimination reaction is here sodium bromide is coming out and alcohol is also forming. Okay, means also you can understand from the methyl group H and from the middle carbon Br, HBr is going. That is the case of elimination, and HBr quickly it will convert to NaBr, and that H, when Na will come from the alkoxide, that time H will come to the O and it will form methyl alcohol. Then this I have told you that due to the elimination reaction you are not getting ether, you are getting alkene. Question is asked. Phenols are also converted to ether by this method. In this phenol is used as the phenol oxide moiety. If phenols you are using, then phenols are also converted to ethers. But phenols are also converted to ethers by this method. But what will happen? In this method, phenols is used as the phen oxide moiety. MOIETY, moiety means phenol plus NOH, both places OH is there. Phenoxide, this phenol means OH is there, NOH also OH is there. Then here what happens? Here from the phenol only H will go and it will form a phenoxide. O will be negative, and H is going as H positive. H is going as a H positive. Then Na will go there. Because O is negative, Na will join there. It will form sodium methoxide. And now you can say that water is already this thing, OH and H. OH and H, it will form water. Then now there with O, Na is attached. Na is attached. Then now what will happen? If now in next step, if it is used with Rx, you have to use Rx halide, then the sodium phenoxide is there plus Rx. Then now simple reaction, Na and R will form, Na and X will form NaX. NaX like NaCl, NaBr, Ni like that. Halide you can say. Sodium halide, it will form NaX. And in the place of Na, R will attach because Rx is there. When bond will break, X will take electron. R will be positive. And there ONA, Na will go as positive, O will be negative. Then from that O negative O, positive R will join. And it will form what? It means ether you will get. One side phenol, other side means one side benzene ring, other side alkyl group. One side phenol group, other phenol means one side benzene ring is there, other side alkyl group is there, R is there, in the middle O is there. Okay. Then here phenols are converted in this reaction, phenols are converted to ethers. In this method, phenol is used as phenoxide moiety. Then you will get C means oxygen will be in the middle, one side benzene, other side alkyl group will be there, like methyl, ethyl, like this way. And now I am stopping only here. Next class I will continue properties of ether. Thank you.